We have another formula we have to consider at this point of the course. It's some ways similar to the distance formula, but it's also very different. And it, for better or worse, it also involves 2 points, an x1, y1 point and an x2, y2 point. It's called the midpoint formula, and there's a handout posted in Canvas of these notes that you're looking at right now. And let me just refer to a slightly larger picture here so I can set up the situation. Suppose we start out with 2 points, x1, y1, x2, y2. Now we can draw a line connecting them up. We know how to find the distance between those 2 points using the distance formula. But now what we're going to talk about is how do we find the coordinates of the point that's exactly in the middle? What are the coordinates of that point? And we're going to have a formula. We're actually going to have 2 formulas because there's a formula for the x coordinate and a formula for the y coordinate, and they're both calculated in a similar sort of way. And the one way to think about what's going on here is to, let's actually call this midpoint maybe AB, and then I'm going to label some coordinates here on the x-axis. This is x1, this is A, this is x2, this is y1, right about here is B, and then up here is y2. If you imagine, we're going to draw 2 triangles actually. In this picture, we're going to draw a line across and up to AB, and then we're going to go across and up to the x2, y2 point. We can calculate the sides of these triangles again using subtraction of coordinates. The length from x1 to A is larger minus smaller, A minus x1. From A to x2 is larger minus smaller, x2 minus A. So this side right here has length x2 minus A. This is A minus x1. And then we can do a similar thing with the y's. I'm just going to label these. This is B minus y1, B minus y1. And this side is y2 minus B. And this same diagram is on the handout. Now these 2 triangles are what we call congruent. They have exactly the same size and shape. They both have a right angle here. By principles of parallel lines in geometry, these 2 angles must be equal. These 2 angles are also corresponding angles. They must be equal. And then these 2 hypotenuses of the 2 triangles have to be equal because we said AB is the midpoint. Whenever 2 triangles have all 3 angles matching up and a side of one equals the side of the other, the 2 triangles have to have exactly the same shape. And so that means that the side A minus x1 has to equal this other side, that x2 minus A. And we get a little equation there that we can solve for A. I'm going to add A to both sides, so I get 2A minus x1 equals x2. I'm going to add x1 to both sides, and so that's gone. I have 2A equals, I'm going to write this as x1 plus x2 with the x1 first. And then if I divide both sides by 2, A is equal to x1 plus x2 over 2. And you can do the same thing with the y2 minus b side and b minus y1 side, and you get a similar formula for b, which is going to equal y1 plus y2 over 2. I'm not going to go through those steps. So here's the y-coordinate of the midpoint, here's the x-coordinate of the midpoint, and that's summed up in this diagram on the handout. Then a little bit of a description of where the formula comes from, and then in the box here is, again, it's like there's an x-coordinate of the midpoint and a y-coordinate of the midpoint. So I like to just draw them both in parentheses. And now let's go ahead and do our problems here. These are going to be not too intense, I don't think. So here's my just summary of the midpoint situation and the formulas. There's like a formula for the x-coordinate of the midpoint, formula for the y. This is what I was calling A and B. We don't have to call it A and B anymore. We can just say how you would get the value here and the value here. When you add two numbers and divide by 2, that's called taking the average of two numbers, like when you have two test scores and you add them together, divide by 2 to get your test average. So I often think of this midpoint formula as just being about the average of the x's, and the average of the y's gives me the coordinates of the midpoint. That's a nice way to remember that. So let's go ahead and do our exercises, start our exercises. Find the midpoint of the segment connecting 0, 8, and 6, 16. So we're going to get an x-coordinate, and we're going to get a y-coordinate separately. The x-coordinate I get by adding the two x-coordinates together and dividing by 2. That's 6 over 2, which is 3. The y-coordinate of the midpoint I get in the same manner by taking the y-coordinates, 8 plus 16, and dividing by 2. That's going to be 24 divided by 2 is 12. And so the midpoint is going to have two coordinates. Now it's going to have the x-coordinate 3 and the y-coordinate 12. That's the midpoint of the segment connecting the two given points. And we'll do a couple more where I think we're only just thrown in some negative situations, because here we're going to find the midpoint of the segment connecting 3, -2, -4, 5, and I think I have a picture drawn of that one. So if we imagine connecting those 2 points up, we're trying to find the halfway point between those two. Where's the midpoint? And I just want you to think a little bit of it. It's probably not even that hard to eyeball it on this picture, but it's neat that these calculations work just fine even if negative numbers are involved. You might not have taken an average of a positive and a negative number before. The x-coordinate, we're going to take the average of the x-coordinates, 3 plus a -4, and divide by 2. 3 plus -4 by 2, that's -1 over 2, or -1/2. The y-coordinate of the midpoint, we're going to take the average of the y-coordinates, so -2 plus 5 divided by 2. That's 3 over 2, or 3/2. So our midpoint here is -1/2, 3/2. Or if I were to try to plot that, it's a little bit easier to think of that as -0.5, 1.5. Let's go back to my picture. -0.5 is about here. 1.5, I think that's where our midpoint is, -0.5, comma. I don't think I would have picked that one out, because I wouldn't have picked a spot. If I did that by eyeballing, I wouldn't have picked out a spot in the middle of a square, but that midpoint turns out to be in the middle of a square. Okay. All right, one more here. Find the midpoint of the segment connecting -6, -2, and 6, 2. So x-coordinate, we're going to take -6 plus 6 divided by 2. I get 0 over 2, or 0. You're not used to thinking of 0 as the average of two numbers, but 0 is the average of -6 and +6. And for our y-coordinate, I'm going to take -2 plus 2 divided by 2. I get 0 divided by 2 again. I get 0 again. So here, the midpoint is just the point 0, 0. It's just the origin point on the graph. So we can get 0 coordinates in this midpoint calculation. And we've got one more exercise here we're going to do. And it's a little bit trickier, a little bit. Let's see. Oh, that's right. So here's the given problem. 6, 8 is the midpoint of a segment connecting the points A and B. If the coordinates of A are 2, 3, find the coordinates of B. So we're playing a little twist on things here. It's not quite like just plugging in. I'm not going to draw this accurately. I'm just going to do a real rough sketch here. But we're saying this point A is 2, 3. We're saying 6, 8 is the midpoint. And we're trying to find the coordinates of a point B. Okay, so we're trying to find, maybe I'll call this XY point, and we don't know what that is. Now, I got to kind of work backwards through the midpoint formula here. The x-coordinate of the midpoint, well, I know what the x-coordinate of the midpoint is. So 6 is equal to the average of the x-coordinates at the endpoints. So that's going to be 2 plus x divided by 2. The y-coordinate of the midpoint is 8. We know it's 8. And we know that's going to be the average of the y-coordinates of the endpoints, 3 plus y divided by 2. So we're working backwards from the midpoint in one of the given points to get the point at the other end. And I can solve for x and y in these two equations. I can multiply both sides by 2. I get 12 is equal to 2 plus x. Subtract 2. 10 is equal to x. Multiply by 2 here. I get 16 is 3 plus y. Subtract 3. 13 is y. So the point B is the point with x-coordinate 10, y-coordinate 13. That's 10, 13. So not too tricky, but not too intense with the algebra. But we've found the other endpoint of that segment. And that's the end of our midpoint discussion.